And we started. We're on air. Hello. Hopefully, all you 0 followers out there will enjoy this. So, now that you've seen me, I'm going to make myself disappear, which is kind of fun. Alrighty. So, this particular derivative right here, we have some derivatives we cannot figure out the antiderivatives to. Okay, unfortunately. We have a lot of methods. I'll show you some of those methods. In BC Calc, we go through a few additional methods, but there are, in fact, hopefully, I'll show you the video because I have a quiz on it. I think I did last down. It's called The Great Smackdown. It's integral versus derivative, and these two guys have a fight of which is better. It's kind of cool. I enjoy it. It happens at William Mary College, and they go through and have a discussion, and the guy makes a comment, yeah, we have some derivatives, we can't figure out the antiderivatives, and I believe this is one. So the only way we could do it is by doing numerical approximations. We know what the graph looks like because we can graph it, and these are two examples here. This graph is supposed to go through there like this. That this obviously, because this area is not covered, is an underestimate. And over here, this is an overestimate. And so we have a couple of ways that we can deal that are a little bit better than rectangles. And the book talks about them. And the one that AP wants me to focus on, rather than all of them, is the one called the trapezoidal, using trapezoids. So I'm going to review a few trapezoids, and I drew a trapezoid here. It's kind of hard to see. And so this is the same curve. And you can see here, there I have, it's an over approximation, but not by much. Right? It's just got a little sliver that it's above. So you're going to have to know, you know how I said you got to know how to figure out the area of a square, a triangle, a rectangle, and a circle. You're also going to have to know how to figure out the area of a trapezoid. Okay? And this is the trapezoid I have right here. And I wrote down the area of the trapezoid right here. That's the formula. I'm going to use kind of this model, 1/2 rather than divide by 2, times h plus b1 plus b2. And I'll talk about what those are. So this is probably the most typical trapezoid you see. I'll do it over here. I'll do a little proof because I like this proof. And so you have two sides. Do you remember this from geometry? These symbols meaning they're parallel. So a typical trapezoid, you have two sides, the opposite sides are parallel, and the other two sides are not. And the two parallel sides are given names, like thing 1, thing 2. And actually, B1, B2 was before Dr. Seuss, and he stole it from math people because he thought it was pretty cool. So here's base 1, here's base 2. And so to prove what the area of this is I'm going to make an identical trapezoid to this, and I'm going to flip it, so it's going to end up looking, let's see if I can do it correctly, it's going to end up looking kind of like this. So now B2 is on top of here and B1 is down here. And so what that's a picture of is a parallelogram. So now these two sides are parallel. And this is the height of the parallelogram. Is this kind of bringing you back to geometry a little bit? And the area of a trapezoid is base times height. Do you remember that? And this distance all the way across is the base. So that's going to be B2 plus B1, or B1 plus B2 times the height. But I'm only interested in this shaded region, which I know is half of the other region because I just duplicated it, correct? So the area of the shaded region is just half of that. So that's my proof of the area of a trapezoid. It's one of the very first proofs I'd ever learned when I was a sophomore, and I got 10 points on it, and I got all excited, okay? So I figured I'd get that excitement back, and I can see you guys are just pumped for that. So thank you very much for indulging me, all right? I'm going to come over here, and I'm going to take a look at this trapezoid, and I'm going to figure out its area, and it's a trapezoid that is a special trapezoid. We usually see trapezoids on their sides. So if I take that trapezoid and put it on its side, it would look like this. And I don't know if it's called a rectangular trapezoid. I'm not sure, but not rectangular, right trapezoid I meant to say. Rectangular trapezoid, that would be dumb. Right trapezoid, because it's got two 90-degree angles in it. I don't know if that's the name of it or not. But that's what we have here. And so here is its height. And so this has been obviously rotated to look like this. So now here's the height. Here's those 90-degree angles. Here's those parallel sides. And over here is B1, B2, and so here is B1, B2. Can you see this okay, Hannah? Okay. Your hair is getting long. Okay. It sometimes covers your eyes. Okay. So I got to make sure you can see that okay. So the area of this thing will be 1/2, because it's a trapezoid. So what is this? So if I take a look, this is a small drawing of this, correct? So this is H, right? In terms of calculus, what would I call H? Say it again. But you said it right to begin with. B minus A. In fact, I'm going to say it's B minus A over 1. Because I have one trapezoid. Okay? And so, and then I have this B1 plus B2. Well, here's B1. Here's B2. In terms of calculus, what's B1? F of A, awesome. Plus, what's B2?
F of B.
F of B, wonderful. So I could say that A in this case is B minus A over 2 times F of A plus F of B, like that. And if I knew A and B, off to the races I would go. Correct? We okay with that? All right, page 2. Well, what I did, this right here is 0. This right here obviously is 2. So this is going to be 1. This is going to be 0.5. This is going to be 1.5. Megan, I subdivided these equally. In other words, these lengths all go up by 0.5. Would you agree with that? Okay. And here I have a trapezoid, and I'm going to call it trapezoid number 1. Here I have a trapezoid. It's trapezoid number 2. Here's a trapezoid, my favorite trapezoid. It's trapezoid number 3. And here's a real popular trapezoid. I don't think it's too cool, but it does. It's trapezoid number 4. So, trapezoid, I'm going to approximate this. And I'm going to first write trapezoid number 1. It starts out with a half, correct? Why? Because it's a trapezoid. It's 1/2 the height. And remember, the height is right here. The height is right here. The height is right here. The height is right here, correct? 1/2 the height times, in parentheses, base 1 and base 2. So, what's my height here? 0.5. I'm going to write a half. Are you okay with that? Parentheses. Megan, I'm going to pick Megan. Nikita, I'm going to pick Aaron, okay, because you answered the question. Are you okay with that? I do not want to hurt your feelings, okay? Here's base 1 to begin with of this trapezoid. Would you agree, Aaron?
Yes.
What would be it in calculus?
1. F of 0.
F of 0. Thank you. I'm not saying you're wrong. I just want F of 0 right now. Okay? Are you all right with that? But it is 1. You were right. Okay. Plus, what's F of B? Excuse me, what is B1? F of 0.5. So that's my first trapezoid. Right, Aaron? Okay, Megan. I got 1/2 because it's a trapezoid, right? My height, would you agree it's a half?
Yep.
Okay. What is B1 and B2 in trapezoid 2?
F of 0.5 and F of 1.
Okay, Hannah, my third trapezoid, it's 1/2 because it's a trapezoid. It's 1/2 because it's the height. So now what is B1 and B2?
F of 1 and F of 1.5.
Okay, very good. And Cullen, I have my fourth trapezoid. I'm figuring out the area of a trapezoid. That's why I need a half. Its height is a half. And what is base 1 and base 2?
F of 1.5 and F of 2.
Okay, would everybody agree with that? 1, 2, 3, 4 trapezoids areas that I'm adding together. Correct? All of them are being multiplied by a fourth. Would you agree? So I'm going to factor out that 1/4, or it's 0.25. And I'd have F of 0 plus 2F of 0.5 plus 2 of F of 1 plus 2 of F of 1.5 plus F of 2. Brady, would you agree with that? Why do I have 2 of F of 0.5s and 2 F of 1s and 2 F of 1.5s?
Because they're like the sides of 2 trapezoids.
Yeah, this is B2 on the first trapezoid and B1 on the second. And this is B2 on the second, and B1 on the third. And then this one is B2 on the third and B1 on the fourth, correct? They share those sides, where A and B aren't sharing their sides. Would you agree? Would everybody agree with that? Okay. So, let's put in some numbers in here. Well, I got 1/4. Erin said that's 1 when she puts it in. Remember, our function is this, right here. And she said you put 0 in there and you get 1. I have no idea what that number is. This, I think I know. I put 1 in here, and I cube it, I get 1, and 1 plus 1 is 2, and you get the square root of 2. Now, before there was a calculator, we had tables. And the square root of 2 shows up a lot in math, like the square root of 2 over 2, right? And I think it shows up on a 30, 60, 90-degree triangle, I think. So we had to know the square root of 3 and the square root of 2. So the square root of 2 is 1.414. It's like when somebody said I had dementia in BC Calc. Okay, I will remember that. I'll forget my kid's name and still know what the square root of 2 is. It was Abby. It was this class. Okay, so I know it's going to be 2.828. I got to apologize now to the BC class. I don't know this one. And if I put 2 in there, 2 cubed is 8, plus 1 is 9, and the square root of 9 is 3. I know that's 3. The rest of it you guys have to figure out. What is this? For those people that have the machine in front of them. I'm seeing if I have the answer. I don't even know if I do. $3.283. Does that sound right? No, that can't be right, is it?
You're adding 3. Oh, it's.
But you're dividing by 4.
That could be right.
See, that's the thing you got to remember. I'm going to tell you, when I did trapezoidal rule, I'd forget to multiply by that thing.
Yeah, you just.
And then I would scream. My answers were bigger than they should have been. Is it 3 point something? Is it?
Yeah, I got 3.28.
3.28, you said 3?
Yeah.
3. So we'll go with that. I think that's correct. So it's approximately 3.283. Okay? Now, everybody okay on that? I'm going to generalize it. 1/2. Why? Because it's a trapezoid, correct? Because I did that beautiful proof. That is another thing that I won't forget. Plus, the proof of how you prove that the square root of 2 is an irrational number. And the proof of the fundamental theorem of arithmetic. Those are 3 things I'm never going to forget. Times. How did this half come about? Somebody's told me this, or maybe I did. How did I come up with that? This was 0.5, this was 0.5, this was 0.5, this was 0.5. Say it again. B minus A divided by what?
1.
Well, I got 4 of them though. So 2 minus 0 divided by what? 4, right? So I think B minus A divided by the number of trapezoids I have, correct? Right? Would you agree with that? So that gives me B minus A over 2n. Are you okay with that? Now, f of A is okay, isn't it? But then I'm going to have a 2 times f of C sub I. Remember, C sub I is that little x that moves along the x-axis at equal amounts, right? Do you remember that? And I'll have another one, dot, 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 till I get to f of B. Remember, A and B don't share sides. I believe that's what, Brady, you told me, correct? All those other ones do. This is called the trapezoidal rule. Yes, sir.
Would the C sub I start as f of A though? Like,
It's 1 over.
It always starts like that?
Yep. In this case it is. Because we're going to say C sub I is A plus.
Oh.
Remember? C sub I we defined as A plus delta x times I, or B minus A, and we start at 1, so it's 1 unit over. Are we okay with that? And it's not going to get to the end. We want to be 1 short of the end. Okay. Are we all right with that? Okay, next page. Is there a next page?
No.
Is that it? Really?
I did they only have 15 minutes? You have like 40 minutes.
Huh. Alrighty. You have a blank side?
Yeah.
Okay. You ready for the blank side? These are like short notes. That's why Rosie was so insistent that I want to make sure I give you the same ones I gave the other class. Oh yeah, here it is. Alrighty. So we have this graph. Can you see this okay yet? And it looks like this. I'm only going to draw the first quadrant. Here's 5. And it's a parabola going down. Correct? Everybody okay with that? And right here I'm going to have 1. Right here I'm going to have 2. And so I'm going to figure out the area underneath this portion right here. I'm going to try shading. Failed again. Okay, something like that. And we're going to use it, so in other words, you'll be told, and now this one obviously we can do calculus on. And we want to approximate using 5 trapezoids. Okay, and so just a reminder, and we're going to use the trapezoidal rule, it's going to be B minus A over 2n times f of A plus 2 f of C sub I plus, and this could be a bunch of things here, just remember that, f of A. So I'm going to wait till Allie gets caught up. Are you ready?
Yeah.
What's the number that goes here?
1. Oh, 5.
Well, there's a number right here, right?
Yeah.
Okay. What's B?
2.
What's A?
1. So 1.
2 times
10. So over 5. So 10.
1 over 10?
Yeah.
Perfect. Okay. Parentheses. Marine. Ready? F of what?
1.
Perfect. Plus 2 times F of?
Is it 1.5 or 1.5?
1.5 would mean
Wait, do we need 5 trapezoids?
I need 5 trapezoids.
Divide that by 2. So it's 1.2.
1.2. Okay, perfect. Plus 2 times F of
1.4.
plus F of, I need a 2 out here, sorry. 2 times F of
1.6.
0.6, and why did I write a 5? I don't know. Do I keep going?
You need F of 2.
So I gotta keep going. 2 of F of 1.8,
8.
because I'm going up 0.2 every
Yeah.
single time, right? Till I get to
2.
2. And now I'm at 2, so it's just that. Correct? questions about those numbers?
Isn't that 6 trapezoids?
Is that 6 trapezoids? I don't think so.
Yeah, you have 5. You have 5 different numbers.
I don't think so.
No,
So it's just 5. There's gonna be 6 numbers.
Can I explain why? Okay. I got 1/10. You're cool on 1/10? So f of 1 plus f of 1.2 is 1 trapezoid. Correct? Plus f of 1.2 plus f of 1.4 is the next trapezoid. Plus f of 1.4 plus f of 1.6 is the next trapezoid. You want me to keep going? Because my hand's getting tired. Are we okay with that? All right. So, what is the answer to this thing? Yeah. I'm calculator free today. Why did you start today?
I just took one of these effective.
Do you have a calculator?
Yeah.
Why did you look at your bag?
It's in there. I just want to cleanse myself from the machine today.
Oh.
Yeah.
I'm going to cross this out, Cameron. Is that okay? Because it irritates me. Because my hand's sore from writing all that. That's why. It's different. It's different than a rectangular one where you just count them up. Okay? It's better to just keep going like Maureen says. When I get to 2, I know to stop. And don't multiply by 2, right? Because that side doesn't have an adjacent side to it. Anybody come up with that?
I got 7.34.
I got this. 2.667. Get your contacts on today? Does that wire bug you? You don't even notice it after a while, do you? Okay. Josh, does it bother you? Huh? No, it does. Now that I mentioned it? Yeah, sorry. Are we okay with this? Okay? I'm going on to the next problem. Now, I've showed you the trapezoidal rule. It only works when you subdivide equally. In other words, we went by 0.2 every single time. This is what AP loves to do. Here's a problem. This is my walk with Rosie. They love giving you a table. And this will be worth 9 points on the AP exam. And they'll tell you this is time. And that it represents minutes. And down here, this is velocity. And that is feet per minute. And then they will do this. 1, 2, 3, 0, 1, 3, 7, 8, 10, 10, 12, 14, 15, 15.5, 15.7. And this is a non-calculator question almost every single time. And they'll ask you to do this. A, for 3 points, approximate with 5 trapezoids. Write using correct units and explain your answer in the context of the problem. And you don't get to use a calculator. So, you start. You go, Kruger always said a trapezoid starts with a half. What is its height? What?
Like the trapezoid.
Of the trapezoid. Remember, the trapezoid looks like this. So you would take 10 minus 0 divided by 1? No.
So you do like
What would you do?
You divide by 5.
5?
5 trapezoids.
Yeah, but they're not all of equal length.
So,
This has a difference of 1, this has a difference of 2, this has a difference of 4, this has a difference of 8, this has a difference of 10. How many velocities did I have on these 10 minutes of walking? Only 5, only 1, 2, 3, 4, 5, 6? How many velocities are there? Infinite. It's continuous, right? I had to be walking at 11 feet per minute. I had to be walking at 13 feet per minute. I had to be walking at 14.5 feet per minute. I have to be, because that thing's continuous. There's an infinite number of them. So if my trapezoid looks like this, what's my height of my trapezoid? If this is my height right here. Yes?
it's the like 1 minus 0 and 3 minus 1.
It's 1, right?
Oh, for the first one.
Isn't for the first one 1? So I'm going to write down 1 times. Remember, I got to do this by hand. What is B1? In other words, what's this length? 10. Plus, what's this length? 12. I got 1 done. I have 4 left to do. Plus a half times. Well, now this is B1, and this will get, well, this will, this is my A and this is my B, correct? So what's this distance on my trapezoid? 2 times. Well, it's going to be 12 plus what? 14. Plus 1/2 times. Well, now this is my A, and this is my B. 3 is my A, 7 is my B. So what is it going to be here? 4. That's B minus A. Okay, so what am I going to have here? Well, I ended with 14, so it's going to be 14 plus what? 15. Plus, here's A, here's B. 1/2 times what? Here's my A, here's my B. 1. 15 plus what? 15.5. Would you agree with that? Plus 1/2 times, 1/2. Here's my A, here's my B. So what's that going to be? Times what? 2. Does everybody see where I get 2? And I have 15.5 plus 15.7. Now realize, you're doing this by hand. So, 10 plus 12 is 22. Half of it is 11. Plus 12 plus 14 times 1. 12 plus 14 is 26, times 1 is 26. Plus 14 plus 15 is 29, times 2, right? 58. Plus 15 plus 15.5 is 30.5. Half of that is 15.25. Plus 15.5 plus 15.7 is 31.2. This is 1, so it's 31.2. So I'm going to add this up. 11 plus 26 is 37. 37 plus 58 is 95. 95 plus 15.25 ends with a 0.25, and it is 110. And 110 plus 31.2 is 141.25. Right? They think you should be able to add that all up.
4 5. It's 4 5.
4 or 5, sorry. You should be able to add all that up. It's 141.45 what? What is it? Feet. Now, I've got 2 points so far. Kruger walked 141.45 feet from 0 to 10 minutes. I now have 3 points. I'll get a point for this work. I'll get a point for this answer. I'll get a point for this justification. Now, what if I wrote 0.25 here? I would have gotten 2 out of 3 points, which is still in the 5 range. They don't care that you don't know arithmetic. They want you to know that you can figure out trapezoids, and that you understand that the unit is correct, and that you know what it means in the context of the problem. That's 3 out of 6. Excuse me, 3 out of 9. B, estimate the acceleration at t equals 7.5. This is what they're checking. What's the relationship between velocity and acceleration? I've talked about it a lot in this class, haven't I? What is it?
Velocity is the derivative of
Acceleration's derivative of velocity, correct? Slope of a tangent line. I go up here and I'm excited. 7.5. Poop. It doesn't exist. I don't even know what the derivative is. So if I can't use the slope of a tangent line, what do I use to approximate it? Slope of a secant line. I've talked about that endlessly, it feels like. What do I need for slope of a secant line? 2 points. What 2 points am I going to use? I'm going to use this point and this point. So, and I have to show my work because I don't have a calculator. So I'm going to use the slope formula. What are my y's? 15.5 minus 15. Biggest mistake is people use 7 and 8. Time is going into the function, isn't it? And down here I'm going to have 8 minus 7. And I get 0.5 over 1, which is 0.5. I have to have the correct units. This is feet per minute. These are minutes. So you could write feet per minute per minute. You can write this down. There's nothing wrong with this. That is correct. Most often people write feet per minute squared. I just got 2 more points. I have 5 out of 9. Then they'll say this: what's your average velocity? And that blows my mind. You know how many velocities there are in 10 minutes? Infinite! How is that even computable? How do I figure that out? You're on a roll.
You know how far you went? So you can
No. How do you know how far I went?
because you did that in the first place.
Show me how I did that.
Trapezoid.
Yeah, what's more calculus than trapezoid? I gotta make sure you show the right work. What work am I gonna show? Yes, sir.
You take the answer of A, which is
Yeah, I know it's the how did I get the answer of A? And I know I used trapezoids, but what was I approximating? Yeah.
The summation.
No, I'm not gonna write the summation symbol. I'm gonna write a symbol that is the calculus symbol for the summation symbol. Starts with an I. The integral from where?
0 to 10.
0 to 10 of v of t dt. And what am I going to do with that, Abby?
Who's Abby?
Nobody's Abby. What am I going to do with that, Gabby?
You take it over b minus a.
What is b minus a?
10 minus 0.
What is 10 minus 0?
10.
Why am I happy about dividing by 10?
You just move the decimal.
I just got to move the decimal because I don't get to use a calculator. So, what is it? It's going to be 14.145, and I did all, here's my work that I had to show, which really was no work at all, but it's telling the AP people that I know what average velocity and how to compute it. What's my unit? Feet per minute, and I'm done. I just averaged an infinite number. I just took like my total distance, like Kyle was saying, and divided it by my time. That always gives me average velocity. Okay? So I have a bunch of problems like this that are setting you up for the AP exam.